now let's take a look at significance tests for the difference of proportions. So the null hypothesis is going to be p sub 1 minus p sub 2 equals the hypothesized value. We're often interested in situations in which the hypothesis value is 0. So there's two ways to write the null hypothesis. That p sub 1 minus p sub 2 equals 0, or p sub 1 equals p sub 2. Either one is fine. What's important is that you can recognize 0 as the null hypothesis value. So then when you're looking at your p-value and comparing to alpha, when you make your conclusion, you know it's about there not being a difference. Then your conditions are the same as before that we went through with confidence intervals. Random samples both have to have samples that are less than 10% of their population, and then your large counts for both groups. So let's look at checking some conditions. Researchers designed a study to compare the proportion of children who come to school without eating breakfast in 2 low-income elementary schools. A simple random sample of 80 students from School 1 found that 19 missed breakfast today. At School 2, a simple random sample of 150 students included 26 who missed breakfast today. More than 1,500 students attend each school. Do these data give convincing evidence of a difference in the population proportions at the alpha is 0.05 significance level? So part A is stating the hypotheses for performing a significance test and to define your parameters. Part B, check if the conditions for performing the test are met. So our null hypothesis is that there is no difference, that p sub 1 minus p sub 2 equals 0. And the alternative is that there is a difference, so it's just not equal to 0. In our problem, it doesn't state that one is higher than the other, so we're just looking at no difference. That there is a difference. And then we define that p hat 1 is the true proportion of students at School 1 who missed breakfast, and then p sub 2 is for the second school. So we check. Both are random independent samples of students. You have 80 from School 1 and 150 from School 2. Both are less than 10% of all students at the school. And then our large counts are all greater than or equal to 10. So now, how do we actually calculate our test statistic? So on your formula sheet, again, you have standardized test statistic equals statistic minus parameter divided by the standard deviation of the statistic. So here we have it all in our notation. Z is equal to p hat 1 minus p hat 2. That's your statistic because it's a difference, minus the parameter is that null hypothesized value of 0. And then again, the square root of the sum of their standard deviations, p1 times 1 minus p1 over n1, and p2 times 1 minus p sub 2 over n2. Alright, so really whenever we are doing this in the denominator, p times 1 minus p, unfortunately we don't know the common value of p, because remember, we have two different groups. So to estimate p, we combine or pool the data from the two samples. So the way that you do this is you're actually going to add fractions the way you've always wanted to. So p hat, which is going to go in the denominator to replace this p, is the number of successes in both samples divided by the number of individuals in both samples. So, p hat 1, you have x number of successes over the total number in the sample, and then p hat 2, you have total number of successes over the total number in the group. So we're actually just going to combine their successes and combine their total individuals in the sample. So you're just adding the numerators, adding the denominators. So your final formula becomes this. Alright, so now let's actually calculate a standardized test statistic. So refer to the preceding example. The two-way table summarizes the data from the independent random samples of children at School 1 and School 2. We already confirmed that their conditions for performing a significance test are met. So we're going to explain why the samples give some evidence for the alternative, that there is not a difference. Calculate that there is a difference, and calculate the standardized test statistic and p-value, and then make a conclusion at the significance level of 0.05. So the observed difference in the sample proportion, 19 out of the 80 minus 26 out of 150, is 0.0642, which gives some evidence in favor of the alternative that there is a difference because that is not 0. So now we're going to pool the samples, we're going to combine them to get our combined p hat, So 19 plus 26 out of the 80 plus 150. And then filling in our values, we have our statistic, which is the difference minus the hypothesized value. Then we have our pooled standard deviation or standard error type idea. So z is 1.17. So using our table, we get 0.1210, but this is a not equals to. This is a two-tailed, two-sided test, so we have to multiply by 2, which gives us a p-value of 0.2420. So because the p-value of 0.2420 is greater than alpha, 0.05, we fail to reject the null hypothesis. There is not convincing evidence of a difference in the true proportions of students at School 1 and School 2 who skipped breakfast today. The formula for the two-sample z statistic for a test about the difference of proportions often leads to calculation errors by students. As a result, your teacher may recommend using the calculator's two-prop z-test feature, which I will do a video on, to perform the calculations on the AP exam. Be sure to name the procedure. Remember to get full credit by using the calculator. You give the name of the test, you identify the test statistic, and you give the p-value. You must have all three of these parts on your paper in order to get full credit for using the calculator.